Okay, the title of this lecture is called the decibel. And we need to find out how to use it, why we use it, and how to calculate it. So that's the subject of today's topic, the dB. The dB was more or less named after Alex Bell, Alexander, inventor of the telephone. And it's called the decibel. There's 10 of them, 10 bells. Decibel. The B is capitalized, or we'll say small d, capital B. That's why it is, because it's a formal name. I don't know why they dropped off the second L of Bell's name. Maybe they couldn't afford the printing costs. I don't know. But the formal definition is 10 times the log of some power 2 over power 1. It's a ratio. We're comparing two powers to each other. Okay? Little red line? We're good. Okay. So, the ratio of powers, some maybe output power over input power. Maybe the power of my amplifier compared to the power of somebody else's amplifier. Maybe absolute power, like 300 watts compared to 1 watt, in which we call that a reference standard. Now, first of all, I'm going to ask, why the dB in the first place? What's up with the log thing? Okay, we'll go to that in a minute. And to answer that is that the world around us, both light and sound, it all operate on a logarithmic scale. If I was to, for example, increase the volume of an amplifier from 100 watts to 200 watts, you'd say, wow, you doubled the power. But you know, in the real world, that will just be higher. That'll just be just an inch louder. So double the power barely gets you any noticeable volume gain whatsoever. And it's like, wow, really? Yeah, so we don't operate in a linear world. We operate exponentially. We need exponentially more power to make it sound twice as loud. In fact, it's a pretty well-established psychological phenomenon that you need 9 to 10 times the power for you to say the following phrase, yes, I think that sounds twice as loud. Now, that is a subjective statement I made. I think it sounds twice as loud. So, 9 to 10 times the power is what they figured out where you would make that statement. Okay, it's not a mathematically derived statement. It's simply a statement that's made as a subjective statement. So, approximately 9 to 10 times the power. So if I have a 100-watt amp, okay, and the freaky dude with the guitar and the pink hair comes up to me and says, dude, I need to sound twice as loud as that. Okay, then you have to be thinking, wow, I need a 1,000-watt amp to please that person, okay? It's got to be twice as loud. And that's a bit shocking. So that's the reason why we logify everything, because the numbers are so huge. When Alex Bell was running cable from Boston to New York, and he was putting amplifiers along the way, and some of those amplifiers would, have numbers like 10,000 and 225,000. But what did that really mean to the human being? I mean, how does it, And so we take the log of it. So it's just a different way of representing very, very large numbers, okay? So the log is there to kind of scrunch these huge numbers into numbers that are more, make a little more sense, and make a little more intuitive sense, okay? So instead of a number like a million, 60 dB is the same way of saying a million gain. It was a million times the power. Or simply 60 dB, okay? And we'll show you how to do these calculations in just a minute. That was just the justification for Alex Bell creating the log system, okay? Make it more reasonable for humans. Now, somebody seems to have stolen all of my wall talkers. I'll have to gather them up. Okay. Let's talk about now the ways that we can use the decibel, okay? It can be a ratio of two powers. Austin powers. Okay. Like two amplifiers. Okay. We could compare I don't know, an 800 watt amp to a 200 watt amp. And find the difference between them. I have to get out some more markers. Not showing up really well. Okay, that's an example. Okay. Now, if I wanted an absolute quantity, okay, for an absolute number, an absolute, let's say, measurement, okay, absolute measurement standard I'm going to put in there. Then we simply put the second power, the denominator, we make it something really simple, like the reference that we're going to be talking about. I'm going to refer this power to a reference. Somebody name me the simplest reference you could possibly think of. The number 1, right? Just put 1 in the denominator. So, dBW, and we put a W on there, and the capital W means that this decibel is referring to 1 watt. Okay? dBW then equals 10 log of P2 over 1, which just don't even bother writing it. So it's the log of a power. Okay? But I retain the W to indicate that this is an absolute measurement derived from the standard, okay, that we are referring to 1 watt. Okay? The reference level is 1 watt. And that's the easiest thing you can do. It's easy to remember. It makes the denominator go away, so it's just like 10 log of P2. So that's the two things typically that we do with decibels. We compare things, or we use it as an absolute measurement. And when we use it as an absolute measurement, we tack on letters to indicate what we're talking about. Okay? That's the reference 1 watt. Okay? There's another dB reference I'm going to talk about, but we're not going to hold you responsible this semester. dBV, and that's referenced to 1 volt. Okay? Another common one is dBu, which is referenced to, this is an odd one, 0.775 volts. It's another standard developed in the early telephony days. There's actually a reason for that, but we won't be going into that. Another one that comes up is called the dBm. That's a small m because that means milliwatts. It's dB referenced to 1 milliwatt. Okay. So those are the different dBs that are absolute values that are found in textbooks, spec sheets. There isn't an audio device that you can buy that doesn't have, as you flip over the specification sheet, at least 5 or 6 references that use dB, as it's. So you need to understand the decibel in order to interpret how good a product is, how sensitive a microphone is, how loud a speaker might be. All of these things are tied to the decibel. And that is absolutely the reason why we absolutely have to learn it. Because the dB is everywhere in audio. Okay? Shows up a lot in video as well, too. So, good thing to learn. So now how do we compute the decimal. There's two things we're going to do with it, and we'll do both of them. But how do you compute it? And I don't suspect that you remember your 10th grade math and remember what a logarithm is. Do you? I sure didn't. So I'm not going to assume that you do. And I'll start from scratch. Okay? First we're going to talk about the definition of the logarithm itself, because we need to understand that before we move on. The logarithm. Let's do the log of x. The formal definition of the log of x is it's the exponent on 10, exponent on 10 to get x. Okay, now that sounds convoluted until I do a simple example, and then it makes perfect sense. Let me do a couple simple situations to explain this statement, okay? If I want to take the log of 100, what is the answer to the statement? The exponent on 10 to get 100. What would the exponent on 10 have to be to get 100? 2. Because 10 to the 2 is 100. So we'll take that 2 and call that the answer to the logarithm. Okay? Now we remember logs. Okay, let's do a couple more examples, because examples means understanding. Let's take the log of, 1,000. What is the exponent on 10 to get 1,000? 3. Yeah, feel free to shout out. Now that's pretty easy. Okay, let's throw a couple on you. What's the exponent on 10 to get 10? 1. 10 to the 1 is 1. So the log of 10 is 1. Okay? Let me throw another one at you. What's the log of 1? 0. Yeah, that's one of those definitions in math. Remember how 10, or anything to the 0 power is 1? Okay, so 10 to the 0 is 1. So its logarithm is 0. Let me throw another one at you. Throw a fastball at you. What would the log of 0.1 be? Remembering that 0.1 is also 1/10. -1. So that shows that we can have negative log numbers. Okay? And we can continue this little process. Log of 0.01, what would that be? Yeah, because it's 1/100th, right? So 10 to the -2 would be the answer. So -2. So that's the log. So, I guess I could go further up here and say, what's the log of 10,000? 4. Basically, it's count the zeros, isn't it? What's the log of 10 to the 6th power?
6.
Yeah. Well, I'm asking what's the exponent on 10 to get 10 to the 6th? Well, it's 6. Okay. Nomenclature. That's straightened out. Okay. So simply count the zeros. Yeah. Count how many times we move the decimal point. We have to move it right to get to 1. It's -2. So that's the logarithm. Does everybody now remember what the logarithm does for us? It takes very large numbers like 10,000 and scrunches them to very small numbers like 4. Okay? Perhaps to give a little more detail to the measurements, that's why Alex Bell made it the decibel and put 10 log in front of it to make it instead 40. So now we're going to make a chart out of numbers, their logs, and their decibel equivalent, or their 10 logs, okay? So you may wish to grab a blank piece of paper, and we're going to create a table. Because now we know what the log does, it's real easy. So we're going to tabulate these things. I'm going to take a number here on the left-hand side, and I'm going to take the log of that number, and then I'm going to dBtize it, or simply 10 log of it, okay, of that number. And I'm going to start out with 0.001. What's the log of that? -3. So if I was to debutize that, okay, -30. And I'm going to write dB after it to remind you now that is in dB. So all I'm doing is taking a number and giving it a new name. That's what the logarithm in the dB does. Let's take another example, 0.01. The log of that is -2, and therefore minus 20 dB. And the old 0.1, minus 1, okay, minus 10 dB, okay. And let's see, what would 1 be? What's the log of 1?
0.
Okay, good. So what is the decibel? 0. I'm going to pause and think about that for just a second. So a gain, if I took a gain P2 over P1, and that number happened to be 1, in other words, they were equal to each other, there would be 0 dB change. Okay, no change. I like that. Not a change of 1, but it's just a net neutral change of 0 dB. So that's kind of nice. Now let's see. Let's move on to 10, which is a 1. Log of 10 is 1. And so 10 dB. Interesting to note that 10 in the linear world is also 10 in the dB world, the logarized world, if you will. It's the only place where the linear world crosses over with the log world. So 10 times the power would be saying 10 more dB. Okay? And on this one we have 100. So that's going to be 2. For the log of 100 is 2. And so that's going to make 20 dB over here. So 100 times the power would be a 20 dB increase. You following me? It's just another way of saying the same number. There are, however, really, really useful things in dB. We'll see in a bit. 1,000 is 3, and that's 30 dB. And 10,000 is 4, 40 dB. It's pretty monotonous, doesn't it? 10 to the 5th is 5 and 50. And 1 million. $1 million would be 60 dB dollars, right? I have a question on the floor. Go.
So what are the numbers represent again as far as sound? What are they representing?
Well, we're going to get to that. on the left here, these are representing that number, that ratio, P2 over P1. Or when we're comparing it to an absolute wattage, simply the power. Reference to 1 watt, which the 1 divides away, goes away. Okay? And remember, we have the 10 log in front of it. So these numbers are representing, in the case of, we're comparing two powers of an amplifier. So now let's get to a practical question based on yours. Okay? I have two amplifiers. And I want to know. Now, let me preface this with a little fact from the psychoacoustics folks. Okay? And you may wish to write this down in your notes. A change of 1 dB is barely noticeable. That's what we consider typically a barely noticeable change in volume. Barely noticeable. Okay? A 3 dB change is twice the power. It's noticeable, but not significant. A 10 dB change is what causes you to say, that sounds about twice as loud. Again, that's a subjective, not a scientific derivation. That's a subjective statement. Can you log me in on this? Because I might end up using the calculator. Log in on your ID.
Yep.
Okay, so there's a chart. So now we can take numbers like 1,000,000 and compress them down to more reasonable looking numbers like 60. Okay? That mixer in the back of the room has a mic input pre that has 60 dB of gain on there, which means it can bring a microphone that's only measuring a microvolt of output, crank it up 1,000,000-fold so that it's outputting 1 volt. That's a pretty impressive mic pre, really, to have 60 dB of gain. That's a lot of gain. It's crazy amounts of gain. So now I'm going to do a couple examples. Perhaps somebody is trying to sell you an amplifier system, okay? And he's saying, oh my gosh, you've got a 400 watt amp, okay? And that might be worth, well, at $1 a watt, let's say $400. And you want to compare it to a 200 watt amp. That's $200. Well, the salesman's going to say, look, you got twice the power for only twice the dollars, but you're going to have twice the power, so you're going to want to buy that amplifier, right? Oh, well, let's just see. I'm going to dBtize this ratio, 10 log of 400 watts over 200 watts. This is now the ratio form of the decibel. And that cancels to simply 2. Okay? Wow. Now, you have to get out a calculator to prove this to you, but I'm going to give it to you. If you get out the scientific calculator on your computer, okay, you get into the Start Accessories Calculator. Once you get into the calculator, View Scientific, and there'll be a log button there. Okay? If I was to take 10 times the log of 2, okay, the log of 2, and I'll just tell you, is 0.3. So 10 times that is 3 dB. Now, from what I told you just a minute ago about what is 3 dB, well, it is twice the power. Okay? And you can get out a log button. We'll practice with the computer in a bit. Just get out the computer, put 2 in the computer, hit the log button, multiply by 10. You'll find that it's 3.01 to be exact. Okay? But about 3 dB. So the answer is, should I spend another $200 on something that I can barely hear? The answer is no. That's not a smart decision. Okay? Especially the difference between, say, a 125 watt amp and a 100 watt amp, it's only around a decibel increase. You won't even hear that. So somebody tries to sell you, well, you know, this surround system has 125 watts a channel, and this one has 100 watts a channel. I'm going to have to say you better go with the 125. Well, as it turns out, that's barely a decibel of gain, which means absolutely insignificant. So you might as well just take the 100 watt one and save yourself the money. It's not going to do you any good until you get into the 1,000 watt category, where you can say, ha ha, my system's twice as loud as yours. Okay, well, and that's the kind of power you need. So it's the bane of the live sound technician. If he needs to have a huge venue, and it's very quiet when you take a small speaker and play it in a large venue, and you'll need twice the power. Well, you're going to have to up your 100 watt system to a 1,000 watt system, and if that venue is larger, like, you know, a Delta Center kind of thing, then 10,000 watts and 100,000 watt systems are not uncommon in the live sound reinforcement arena, so to speak. So it's those kinds of wattage that we have to deal with in large sound reinforcement applications. 100,000 watts is not uncommon. Okay? So, there you go. Let's do another example. Okay? I'm going to say that one amplifier is 800 watts. And that's only 500 bucks. I'm going to compare it to that 200 watt amplifier, which was a couple $100. Okay? It's getting cheaper. This is $1 a watt, and this is not quite $1 a watt. It's getting cheaper. I'm going to divide those two now, and I'm going to deputize them. 10 log of 4. Wow. Man. What are you going to do? You can get in there, and we'll type in the logarithm. I'm going to go to scientific. I'm going to put 4 in there. Hit the log button. I already knew the answer, but it's actually 0.6. 10 times it equals 6 dB. Okay? Alright, well that's cool. That's just how to do the math. Just a math problem. So is a 6 dB gain worth 300 bucks?
Nope.
Still, I'm thinking not. You're going to have to get that dollar per watt figure down considerably before I'm going to consider a 6 dB increase something worth paying for. At least, you know, I'd pay 100 bucks for it maybe. You know, 300 bucks, but not 5. Okay? Because 6 dB is going to get me, you know, more than barely noticeable, but not twice as loud. So, you know, somewhere nicely in between. It's a significant jump. I'd pay some money for that increase, but it's not gonna get you as far as you think, and that's why we use the dB world, because that 800 watts sounds like a huge deal compared to 200 watts. But the reality of it is it's not that big a deal. Okay, so that's why we need to understand the decibel. Okay, good. Any questions so far? All right. So you want to do one more example? Let's do an input-output example. The gain of a system. Very, very similar. It is the same thing, really, just thinking differently. I have a box, and it puts out 1,000 watts. Okay? And I have a system that puts in 0.5 watt on the input. Okay? And this is just an amp. I want to know how many dB gain it is. Okay? Well, gain is output over input. Okay? So power out over power in, that's your P2 over P1. Gain or measurement of gain in the stock market, number of chicken eggs or whatever, it doesn't matter. It's always output over input. Okay? And so power out over power in. And I'll take the 10 log of that to convert it to dB. Okay? So that turns out to be 10 log of 1,000 divided by 0.5, which equals 10 times the log of what? What's 1,000 divided by a half? 2,000. So that's the equivalent of 2,000. Alrighty. So what you normally would do is just go over to your calculator, okay? And if your calculator's up on your screen, go ahead and do it. Type in 2,000, 1, 2, 3, okay? Hit the log button and multiply by 10. It's 33. I already knew the answer to that. I did it in my head, okay? I don't need a calculator to do any decibel calculations, because I figured out a clever way of doing it, which I'm going to teach you after the break. Okay? Alright, well that's kind of neat. Now I'll do another example. You guys like examples, right?
Yes.
Okay. Examples hammer at home. Okay, I'm going to do an absolute power measurement statement. We're going to use the decibel as an absolute power. So I'm just going to ask you the very, very simple question, okay? What is 4,000 watts in dB? Well, that's a very simple statement. 10 log, okay? I want a dB in dB. I want 4,000 watts. It's an absolute measurement. So it's going to be log of 4,000 over my reference. What's my reference, people? 1 watt. Let's keep it simple. Okay? Let's refer. The only thing that doesn't simple is that old, the dBu, which is referenced to 0.775 volts. That one's a little strange. But for now, we keep things very simple. And so log of 4,000. That's going to be 36, by the way. I did that one in my head, but I'm going to show you that on the calculator. I will type in 4,000, and you may type along with me, and hit the log button. It's 3.6. When I multiply that by 10, it's 36. What did I just say a second ago? Did I say 36? I hope I did. dB, W. W after that, meaning that this is a absolute value, an absolute wattage reference. In other words, I am saying that 6 dBW is the same thing as saying I have a 4,000 watt amp. You could say I'm selling you a 36 dBW amp. And you'd go, great. In fact, I kind of wish they listed those things as 36 dBW amps. It'd be much easier to calculate how loud something's going to get. Okay? Wow. Awesome. Well then, these are the same thing, same statement. This one's in dB, this one's in the linear world. Okay? This one has more value. This one has more dollar value because what? The public is duped into thinking a 4,000 watt amp will solve any problem. That's crazy amounts of power, right? But as it turns out, it's 36 dB of power, which is fairly significant. Okay? 36 dB is enough for that guitar player to come back to you 3 times and say, I need to be twice as loud, man. Oh, okay. No, I need to be twice as loud. Again, twice as loud. And then you got 6 dB left to give him. So 4,000 watt amp is a significant amount of wattage. Probably cost you a bit of money, but it's worth the purchase. Okay? So that's an absolute measurement. And the dBW, of course, indicating that it is referenced to 1 watt. Okay. So I'm now going to do. There's only going to be one application in this class that I hold you to. But I think you need to be introduced to the decibel probably 3 or 4 times in your life before it actually hammers in. And consider this the first one. So if you don't quite get it the first time, that's okay. That's going to par for the course. Try again, hammer it to you again, and I hammer this again in my second class and my third class. And by the time you graduate, dB is really pretty simple and easy to use. Okay? It's the ease of use is why they created it. And you're thinking, nuh-uh. But I'll show you how it can be made easy. All right, I'm going to introduce to you a use of the decibel. There are many, many, many uses. One of them is to measure sound pressure level. Somebody asked that. How does this relate to sound? Well, if you use what they call the sound pressure level decibel scale, okay, that's one practical use of the dB. And I'll go with that real quick too, because that's kind of handy. Okay, sound pressure level. Okay, or SPL, common. We have a reference level, 0 dB, and they went around and interviewed 500 5 and 6-year-olds and said, raise your hand when you can hear this sound in the headphones. And they'd all raise their hands at slightly different places, but most of them at one particular voltage in that headphone. And in 1954 or so, they finally said, okay, that is 0 dB. The quietest sound. And I might say that a child can hear. Most people say that a human can hear. But I know some 60-year-old humans that can't hear the same volume level that a 6-year-old child can. So this was actually based on a quietest sound a child can hear. And we'll call that 0 dB. It was rather arbitrary. It was dictated by 500 6-year-olds. Okay? Who raised their hand when they finally heard the sound. From there, we're going to go up using a dB or logarithmic scale. Okay? And I'll just give you some examples. These are in your book. 40 dB is like a quiet, very, very quiet room. This room would not qualify to be a 40 dB room. Okay? 10 and 20 dB are barely noticeable. That's so quiet. You'd be inside of a very, very quiet, very isolated recording studio. Okay? 55 dB or so. That's a quiet neighborhood. At night. In that area. It's also roughly 555 to 60 dB would be the sound in this room. Just random sounds plus the air conditioner there on the computer equipment. And all of these computers, making the gentle hum in the background. We're in that region here, 55 to 60 dB. Okay? 70 dB might be like a quiet music listening level. Quiet music. Okay? 85 dB sound pressure level is like party music, party loudness. Okay, nice loud party. It also is a unique little spot in psychoanalysts and psychoacoustic people. That's where our ears are flattest. The flattest frequency response when you're listening to it at 85 decibels. So your ears are most balanced. Okay? 100 decibels. can be 100 to 110 decibels, can be a concert level type situation. It depends on if you went to a America concert or an Osmonds concert in the 70s, right? The Osmonds and the Led Zeppelin concert, they had the same sound system, was probably upwards of 120 decibels. It's really, really, really loud. And if you sat in the first row, I'm sure you were deaf for a few days. Okay, so 120 decibels. This is where ear damage can occur. Okay. 130 decibels, like jet engines. Jet engines at like 30 feet kind of thing, you're still far away from it. 140 decibels is definitely the threshold of pain, otherwise known as a Britney Spears concert. Right? Which really occurs at any decibel level, really. In that case. I'm sorry, Brittany, I didn't mean that. She's listening. Okay, so that's an example of another scale that we use that uses the decibel. Okay? Right here, they make sound pressure level meters, which look a lot like the one that's in my cabinet here. I bought this from Radio Shack for probably $39. It's a nice little, this is great for calibrating. If you're calibrating your surround sound system at home, this is a nice thing to pick up. And let's see. Looks like the battery is dead, but I won't get any measurements off this today. But it looks like that. Has a little meter on it, and you just turn it to the various scales. This is the 100 dB scale. If it's +6, then it would be 106 dB. So nice little device to own. I use it to calibrate systems. I calibrated the speakers you listen to in this classroom in surround using that and a pink noise generator. So that's a use of the decibel. How many minutes left do we have on that tape? Does it say on there?
42 minutes.
Good. I won't use. Okay, SPL, sound pressure level. Another use of the dB. Here's another use of sound pressure level. Okay? Maybe, just maybe, we want to know, let's say we got the job to do a live concert, or maybe to design a sound system for, say, a church or a venue of some sort, okay? You might just indeed want to find out how loud your system's going to be. That might be a handy thing to be able to calculate, rather than to kind of guess it in midair. So one thing that speaker manufacturers all across the world, we've all agreed on to measure how loud a speaker is, given a certain amount of wattage input, how loud the thing's going to be. That seems like it would be an easy measurement to do if we just kept it simple. Okay? So I'm going to pretend to measure this speaker. Because the battery's dead, it's going to be pretend. Okay? Suggest to me, how much watts should I put into the speaker as my standard measurement? How many watts? Please, keep it simple. What's the simplest? One. Why don't we make the standard easy for us? Let's call it 1 watt. So I'm going to put a 1 watt signal into that speaker. Now, this thing will measure louder or softer depending on whether I'm closer or farther away from the thing that's making the noise. Isn't that correct? We all know that from experience. So why don't we choose a standard of measurement of distance? How far away should we measure?
1 foot.
He suggests 1 foot, but since we interact in the international community, what would be the more logical choice? 1 meter, okay? Which is approximately 3 feet away. So there you go. That's where I'm going to make the measurement. Now, whatever number comes up on my meter is going to be how loud that speaker is at 1 meter with 1 watt going into it. And we have a special name for that. Okay? It's called our calibration standard. But on the back of every sheet of every speaker you'll buy, it's called the sensitivity rating. Okay? And that means, direct quote, how loud the speaker is, okay, with 1 watt going in, measured 1 meter away. Now we've got a standard. And that standard prevents you or me from lying to each other. Okay? Arlen here can't go off and design his own set of speakers and say, ours is louder than yours, and we're the same price, so buy our speaker instead. Okay? He can't make that statement because eventually he's going to have to make honest disclosure of the speaker's specifications, and they'll send it to some lab somewhere, and they'll make a standard measurement so that nobody can make that statement. Okay? So we're all honest, and so when you walk down to the speaker shop, you'll buy the louder speaker if that's what you're looking for. Okay? And it's called the sensitivity rating. Now, you may be shocked by how loud speakers are with only 1 watt going in. So those of you with computers running, bring up the little E and let's do a search. I'm going to go to this speaker. I'm going to go to this speaker right here. We're just going to use a real world example. This is an NHT model SB3. So type in NHT SB3 and then the words sensitivity space rating. And I'm sure that those speakers were rated. How much? Say again, loud? 86 dB is what he found on a spec sheet. And those speakers are at least 10 years old, if not more. But we found the sensitivity rating. You can do it on any speakers. Proof. Infinity, beta 20. Those are infinities up there. Type in infinity, beta, space 20, space sensitivity rating.
90 dB.
And you get 90 dB. Okay. If the speakers were the same volume handling capability and the same price, which ones would you buy? The Infinities or the NHTs? Assuming they deliver the same amount of power, the same amount of money, which one would you buy? Why would you buy the Infinity? It's more dBs, more bang for your watt. It's 90 dB. How loud is 90 dB? That's louder than a loud party. 86 dB is party volume. These things will deliver you a nice party. Okay? Those things will deliver you, well, what? 4 more dB? Is that enough to like jump up and down about? Not really. But they are louder. So given the same set of circumstances and the same dollar amount, I'd buy those. Now, how come you don't do that? How come when you walk into a speaker store, you don't flip over the rating sheet and go, tell me what the sensitivity is, buddy? Why don't you do that? Because nobody knows how to do it, right? Yes?
Does it take into account like the degradation of sound, like the subwoofer, like anything, or is it just how loud it is?
Just how loud it is.
Okay.
Mm-hmm. Now, that doesn't mean it's a cleaner sounding or better sounding. It just means it's louder. Now, when you're a DJ, what do you care about? Do you care about delivering the most pristine sound of Whitney Houston's latest single to your dancing crowd? Not really. I need volume, and I need volume, and I need it cheap because I got to set up maybe 1, 2 DJ systems, right? Okay. So here's the thing. This moment right here, I'm going to save you the cost of taking this class. And from here on out, it's all profit. Okay? Everything I teach you after this moment is going to be pure profit. I will save you at least the cost of this class when you go, if you decide to go into DJing. And here's how we do it. Speakers are not sold on their so much on their efficiency as they are their wattage. Okay, it's a 100-watt speaker, a 200-watt speaker, a 400-watt speaker. Did it occur to anybody that if you bought a more efficient speaker, a 3 dB, remember 3 dB is twice the power? If I bought a speaker that was 3 dB more efficient, I could power it with half the wattage. Did you catch that? Does that make sense? If my speaker, if this was 87 and I moved to 90, and it took a 100-watt amplifier to get me to the party volume levels I want, well, guess what? 50-watt amplifier will do it for the second set of speakers. Now, since amplifiers are sold by wattage, okay, if you can cut the wattage down, you can save significant amounts of cash, okay, just by knowing to turn over the page and look at the sensitivity rating, okay? Now, I happen to know that's an average sensitivity rating for these little babies. That's a nice sensitivity rating, 90 dB, wow, with 1 watt. Did you know that when you go home and listen to your music, that typically you set your amplifier, it's booming around there between, maybe a watt or two at most. You have that 100-watt amplifier, you almost never use that 100 watts, okay? Because these things deliver 90 decibels with only one watt, So when you're listening at home, your amplifier's kicking around a watt. That's about it. Not much more than that, okay? You need the 100 watts, though, for what? The big, huge explosions in your movies. You need that headroom, because normal talk and normal dialogue and normal stuff in a film, it's taking about a watt, okay? And when the explosion occurs, that's more than double, okay? That's a lot, so it's going to be 100 watts, okay? That's why you need the 100-watt amp for that headroom. But normal listening volume levels are typically around a watt. It's no big deal, okay? But I know of some speakers, DJ speakers, that you can buy that have a sensitivity rating of 100 dB SPL with 1 watt. And if you get the Peavy's, Peavy has a speaker, I kid you not, 103 dB, okay? 103 dB. Just the difference between here. Watch this, okay? If I had a 90 dB speaker and I put 2 watts into it, I doubled its wattage, what would its loudness be? 3 dB more, right? Doubling the watts was 3 dB. I'm going to put these statements up on the board, and I recommend you write them down. 2 twice the power equals plus 3 dB. You add 3 dB to it. Doubled the wattage. Remember how we compared an amp that was twice as big as the other one, and it came out 3 dB? That means one amp is 3 dB greater than the other. I'm going to say 1/2 the power is minus 3 dB. In the other statement I made, remember that 10x is the only place that dB in linear world come across? So 10 times the power is plus 10 dB on the meter scale, the SPL meter, okay? Equivalently, 1/10 the power is minus 10 dB. So this is 90 dB. And I'll put in parentheses to remind you, 1 meter, 1 watt. However, it's 93 dB because I doubled the wattage. If I say 1 meter, 2 watts, it's now 93 dB loud. Okay? If I do 10 times the power, I'll add 10 dB. So it'll be 100 dB. Okay? 100 dB at 1 meter, 1 or 10 watts. With 10 watts going in, I get a 10 dB increase over the two. If I divided the two out, you'd end up with a 10 dB difference. Okay? So now, look at this. This speaker here, remember, is 1 meter, 1 watt. Okay? Wow. So, this means that if I had a 10 watt amp powering this speaker, it would be the same loudness level as this speaker with only 1 watt going in. Now make the logical extrapolation. If I had this thing running at 100 watts, this thing would only need 10 watts for the same volume, the same loudness. Okay, now that's significant. Okay? Because a 10 watt amp, boy, that's a cheap little apartment, little put on the desktop set of speakers. A 10 watt system hooked up to a nice efficient speaker can deliver the same amount as these speakers above us with a 100 watt amp going into it. You start to see the advantage? Let's extrapolate one more time, and this is where I'm going to save you tons of money. Make the extrapolation to the fact that I want really, really loud volume party levels because I need to do large churches and gymnasiums and airplane hangars. I'm going to need 1,000 watts. So I go out and buy that speaker. But the student that took the class from me, however, is going to flip over the sensitivity rating and go, I think I'll buy the speaker that's 10 dB louder and save myself the wattage and then stick to a 100 watt amp. Now what's a 1,000 watt amp cost? Gosh, 1,000 watt amp, it's in the $500 to $600 price range, 100 watt amp? There's not a pawn shop on the planet that doesn't want to have, that has one sitting there for $50. That's what I do. I go to pawn shops and I buy an amp, and then when I blow it up, I throw it away. I don't bother repairing it. I just go to the pawn shop again. Okay? But since I'm using PV speakers, I actually got another double beyond that. I'm using the equivalent of a 2,000 watt amp using my 100 watt apartment speaker system. This thing right here is 100 watts. Got it for $179 from RC Willie. Okay? That's saving you cash. So, the intelligent student flips over the page, looks at the sensitivity rating, and makes a judgment and goes, 6 dB, that's 3 and 3. That's double. That's 4 times the equivalent wattage. Yeah, I think I'll take that speaker. Make sense? Okay, so I just saved you the cost of taking this class. If you ever go out and buy a set of speakers again, take a look at the sensitivity rating, and you'll realize that you can make your home theater system crap loads louder with the same amount of money purchased into the amplifier system. Now, more efficient speakers might cost a little more, but they don't sell speakers based on their sensitivity rating. When did you ever see an RC Willie ad going, "These speakers are 94 dB sensitivity rating. Get them for $400 while they last"? No, because nobody knows what that is. I guarantee you, ask 100 salespeople what the sensitivity rating is, they have no idea what that means. But now you do, and you are empowered to go make decisions that's going to save you and your future company, your contracting company that does live sound, tons of money because you're thinking. Okay? So that's why I thought I would take one use of the dB. What's one use? Okay? Measuring how loud something will be. And that's really easy. So, let's summarize this now. And I'll summarize the equations and some simple things that we can do. Okay? The summary is, remember how I said if I got 1 watt going in, it's 90 dB. 2 watts going in, we doubled it, plus 3 dB. So it would be 93. So, and then if I 10 times the wattage, it would be plus 10. So now you see what I'm saying? The decibel is something that can be manipulated with 5th grade math. Simple addition and subtraction. So now I'm going to go back and review from a different kind of viewpoint how useful and easy the dB is once you learn how to understand it and manipulate it. Okay. You simply take the sensitivity reading, okay, the total loudness, in dB SPL equals sensitivity rating plus the wattage. But the wattage must be measured in dB, so dBW. So take your wattage and convert it, and you have how loud the speaker will be. Isn't it handy if you're going to be designing a live sound reinforcement system? So one more example now from this viewpoint. Now, encompassing, wow, that was really rather simple when you do it this way. If I make the sensitivity rating statement, sensitivity rating of the NHTs equals 86 dB, because we just looked that up. And I'm going to put 400 watts into them. I don't think they would handle that, but I'm just doing it for theory. 400 watts into a speaker that had 86 dB. Well, first thing we need to do is convert 400 watts to dB. 10 log of 400. I know that to be 26 dB, but you don't yet. So we rely on the calculator. I'm going to hit 400, hit the log button, and it will be 26. And multiply it by 10. 26 dB. I did that in my head, however. And that will be dBW. So then the total loudness see, this is what makes it easy now, is it's 86 plus 26. Divide thing in there. So it's 12, carry the 112 dB. Sound pressure level. With a reminder that that's at 1 meter. It's at 1 meter still. Okay, the wattage is now 400. So that's 112 decibels, standing 1 meter away. Bingo. I get my sound pressure level meter. I put 400 watts into the speaker. We assume it can handle it. Put the measurement 1 meter away, and I guarantee you, 112 decibels will show up on this meter. Okay? Yes?
So how do you figure out what the threshold of the speaker is, or how much it can handle?
That'll be published in the specifications. It'll usually say like 400 watts peak, or 200 watts peak, or 1,000 watts peak, you know.
Grab the cables and go. Gotta do preps.
Alrighty. So, we'll do 1 or 2 more problems, and then when we get together next time, Arlen, we're going to show you Wiz's method of doing decibels without using a calculator. You do it in your head faster than a physics student can solve it on a calculator. Okay, and I'll teach you how to do that. Okay, so we'll have fun. A couple more, Examples?
Yes.
We like the examples? Good. Okay. I'm going to have you do this problem quietly. Okay? Okay. I have a speaker that has a sensitivity rating of 90 dB SPL, and I'm going to put 100 watts into it. How loud can it get? Go ahead, and I'll give you the time to figure that out. Okay, we're going to solve this problem. 100 watts, okay, is 20 dB, right? We had that from our lookup table. So 20 decibels. W to represent, that's in watts. And we simply add that to the 90, 120, 90 plus 20 is 110 dB SPL. And that's how loud it's going to get. Okay? One more example, and we'll call it good. I have a speaker that has a sensitivity rating of, let's make it really nice and high, 98 dB. It's a really loud, efficient speaker. And I'm going to put, let's have some fun. Let's put in 800 watts. And I need the answer in dB SPL. I'll give you a moment to figure that out. Okay, if you've got a calculator in front of you that does that, you put 800 into the calculator, hit the log button, multiply that by 10, and you get 29. Is that correct? And so 9 and 8 is 7, 11, 127 decibels. Sound pressure level. That's going to be a very loud concert. That'll be a very loud, and a lot of shows at 1 meter away from the speaker stack are indeed 127 decibels. Quite a few of them get up that high, so not uncommon.
If it isn't, it's kind of like a little off the subject, but if it doesn't matter, like 200 watts difference as far as decibels, then a lot of amps, like a lot of guitar amps that I've seen have been like 200 watts or 100 watts. If it's not that big of a difference, why doesn't somebody just come out with the same price of like a 600 watt and then just, like, why don't they just keep bumping it up a little bit? You know?
Marketing. Most of the people don't understand decibel for the most part, and so that's why it's not marketed that way. But you can say 300 to 400 watts, and that triggers big. That's a big deal. Okay, let's just take that example, and let's find out. You said you can buy a 400 watt guitar amp and a 300 watt guitar amp. Okay, what's the difference to that? 4/3, 1.333. Okay, I'm going to put that into my calculator here. 1.333333, and I'm going to take the log of it. It's 0.125 basically, and I multiply by 10. And that difference is 1.25 decibels. Okay, when I 10 log this, to put it into reality, 1.25 dB. Now what did I say? 1 dB is barely noticeable, right? Barely noticeable change. So 1.25 dB, it's nothing. So the difference in loudness between a 300 and 400 watt guitar amp is nothing. So if you sold it from that perspective, you'd never make any money. But if you sell a guitar amp that's 400 watts and this one's 300, oh wow. But did you know that you could swap out a Celestion speaker in some of the older or not as efficient cabinets and put a more efficient speaker in there and have the equivalent of an 800 watt guitar amp? Just by swapping the speaker out and getting yourself 3 dB more sensitivity on the sensitivity rating of the speaker. And so that's what I'm telling you, folks. I've just saved you the cost of taking this class. if you just simply follow those. Just next time you go buy a set of speakers, just flip over the sensitivity rating or get on the internet and type those words in. It's as simple as that. And then you can make a more informed and more intelligent choice on how much watts you need to fill up your home theater. Okay? So we'll end with that. And next time we get together, I'm going to show you how I can do all those dB calculations in my head. Like 8,000 watts, 10, 20, 30, 9 dB. How am I doing that? I'll show you how to do that next time.